Okay, so now in our notes, we're going to look at translating expressions and phrases and sentences. So basically what this means is we are taking math language and we are turning it into language that Miss Carruthers and Miss Tolley would like, right? We're just coming up with fancy language that says the same thing for math. So when you look at the word addition, what are some things that come to your head? Add, right? More than. Plus. What are some other words that you can think of? What's the big one that we always hear? What is the sum? So you have sum, you have sum, there's total, there's increased by. You can go, we can get really fancy, but those are the big ones that you hear in math, okay? So when you think about subtraction, the big one you hear is difference. Difference, we have minus. We have, if this is increased by for addition, we can do decreased by for subtraction. We have less than. And we have not less than and subtracted from. Now, on subtracted from and less than, I want you to put a star around that and I want you to highlight those two because those are big key words there. We're going to come back to that in a second. But those are your big words for addition and subtraction. Now, let's look at multiplication and division. What's your big one for multiplication? What's that big power word that we use? Product. Product is one for multiplication. You can do times. Another big one is of. Of means multiplications, especially when we're dealing with fractions. Like, that's a really, really big one is of. We can do twice, but twice is specific to 2 times. And then you can do triple the amount, which is specific to 3 times and, numbers like that. Triple and double and all that stuff. When you look at difference, your big one that we always hear, that's a fancy one, is quotient. The quotient of a number and 5 or something. Separate. Division means you separate into specific groups, so separate's a big one here. You can do divided by. And then, of course, you can do half, which is specific to, dividing by 2. And then you can do thirds, which is specific to dividing by 3, right? So those are just specific to certain numbers. Okay, so that's multiplication and division. When we talk about parenthesis phrases, the words that I want you to put here are times the sum of. Because remember, this parenthesis, that means to distribute. So if you have a number out here, what are you doing? You are timesing something, usually by the sum of or the difference of. So when you look for those distributive property words, you do times the sum of something or times the difference of something. Okay, so that's what I want you to look for here for those parenthesis phrases. Remember when I told you to, up here I told you to highlight and circle 2 of those subtraction phrases. The ones that I wanted you to circle are the, where are you going? Is the less than, and subtracted from. And I like to call those my turnaround phrases. And we'll talk about the turnaround phrase because everything is usually in a given order, right? But these 2, we're going to call turnaround phrases. And you'll hear me say that in some of these examples, okay? So go ahead and write those down for your notes. And then I'm just going to kind of go through all of these together so you have as many examples as you can to help you do your homework. And you can pause it and then just jump right back in and then see if you got the right answer. But the product of a number and 3. Product of a number and 3 means multiplication. There's only one way this can be written simplified. So this is how I know if you paid attention to this video. 3 and a number. We know vocabulary here, so I want you to listen to me. This is the most simplified way you write it. Your coefficient is in front of your variable. You will notice I don't use this sign anymore. I will not say n times 3. That is not okay. That's not a simplified way to write it. I don't even use a dot to write multiplication. The most simplified way to write this is stuck together like glue with your coefficient in front. You will get points off if you do not write it just like this. Commutative property says this is okay. But this is not how we write it. We write it with a coefficient and a variable. Is that clear? Okay. So 3n is my answer there. Number 2, the difference between a number and 10. Difference is not a turnaround word, so I'm going to go in order. A number and 10, and difference means subtraction. The quotient of a number and negative 5. Division, the number and negative 5. We don't use this symbol anymore, guys. It's gone. It's just a fraction bar. So no more do we use this sign in algebra. Division's gone. Just the division bar. 4 subtracted from a number. Subtracted from. When you hear that, I want light bulbs to go off and be like, oh, it's a turnaround word. So 4 subtracted from a number looks like this. N minus 4. Okay? Now, if you did write 4 minus n, I want you to look at this while I read it to you. Does this look like 4 being subtracted from a number? No. 9 is being subtracted from the 4. So when you do a subtraction one, I want you to look at, does it make sense? Is it reasonable that it would be written like this? And it's not. So you can see that 4 is being subtracted from n. Like if you had $10 and I subtracted 4 from your money, that would be $6. So really pay attention to the language on that one. Those turnaround words can be tricky. Number 5, the sum of twice a number and 7. Well, sum means addition and twice means multiplication. So there's 2 operations. The sum of twice a number and 7. 2x plus 7. The product of a number and 10 increased by 1. 10n plus 1. Okay, let's go on to that next page. Number 7. 4 less than is a turnaround word, so it means subtraction. A number squared. So a number squared minus 4. 4 is less than a number squared. Number 8, twice a number divided by 5. Number 9, the sum of twice a number and 10 is 36. The sum of twice a number and 10 is, in math, is equals 36. Number 10, 3 times the difference of a number and 7 is 18. 3, that doesn't even look right. Because 3 times what? Times the difference of a number and 7 is 18. I erased my original answer, but I'm going to write it back because I want you to see the mistake that I made. I said the difference of 3x and 7 is 18. But if I go back and I reread that to myself, does that look like 3 times the difference of a number and 7? No, that looks like 3 times a number and 7 is 18. So remember, 3 times the difference of a number, that's where it begs that distributive property. So be careful on that one. I even made that mistake to begin with. So I want you to look closely at this language. Okay, let's look at number 11. 4 times a number divided by 8 is 3. Number 12. 5 times the sum of a number and 6 is 48. Number 13. 1/2 of a number is 8 less than the number itself. Look at that one. Looks tricky. But here, it's 2 pieces. Remember, is equal. So we're going to do this left-hand side. 1/2 of a number is what? Well, here I have this piece. 8 less than the number itself. Well, the number was x, because I don't know it. So it's x minus 8. So when you get that equal sign, notice you got a left-hand side and a right-hand side. Try and piece it together that way. Let's look at this one. The product of a number and 3, the product of a number and 3, product of a number and 3, is the same as the sum of that number and 6. So look at that one. The product of a number and 3, here's is, the same as the sum of that number and 6. Number 15. 15 decreased by the quotient of a number and 3 is 20. Decreased by is not a turnaround word, so we're going to keep it in order. Number 16. 4 less than the product of a number and 7. So the product of a number and 7. And 4 less than that because it's a turnaround word. Here's is, so is equal. 8 more than that number itself. 8 more than the number itself. So those look tricky, but if you work them, they're not as bad as they seem. All right, so now let's talk about what the inequality symbols are. Remember, your symbols are less than or equal to, greater than or equal to. Okay, you should have known those from a long, long time ago. So if I look at this, is less than, because sometimes people see less than and say, well, you said that was subtraction. If it's followed with the words is less than, that's an equality because you've got this equal sign and the equality symbol. So be careful for that. So a number is less than negative 10. Number 18, a number is less than or equal to 8. Number 19, a number is greater than or equal to negative 4. 20, a number is at most 45. So this is where I have to ask myself, oh, that's tricky. If it is at most 45, can it be greater than 45? If it's at most 45, can it be more than 45? It's got to be less than or equal to 45. Number 21, a speed limit of 55. If you go faster than 55, you're going to get a ticket. So it's got to be n is less than or equal to 55. Number 22, a number is at least 16. If it's at least 16, can it be 17? Yeah, it can be 17, 18. It can be greater than or equal to 16. A number is no less than 10. If it's no less than 10, can it be 11? Yeah, that's more than 10. So greater than or equal to 10. A number is no more than 26. Well, if it's no more than 26, can it be 27? Nope, can't be greater. It's got to be less than or equal to 26. Number 25, a maximum number of 25. A maximum of 25. It can't be 26. It's got to be less than or equal to 25. A minimum number of 5. A minimum number of 5 means you can have 5, but you can have more than 5. You just got to meet that minimum of 5. So it can be greater than or equal to 5. Okay, so that is the language that we use for translating. If you have questions, come and see me in tutoring, or good luck on your homework.